All right. So it's 5:30 as per the instruction from the past video or the previous video, part 2 of week 22. Uh, I said that we'll have the session on 5:30 because I have some prior commitments uh, at 6:30. So we will start the session now. So we are going to discuss today Engineering Mathematics week 23 part 1. So as you know, tomorrow also we are going to have the session from 2 from 5 to 6, oh sorry, from 6 to 7 again. That will be another session on engineering mathematics. And today we are having one more session. So today we'll discuss three questions, three quota questions. First, based on limit, very easy question. Second, based on integration. Third based on vectors. Okay, and in between some random questions, some here and there for concept. All right, so let's start. First question, GATE 2010, question number 1. The limit extending to 0 of sine bracket 2 by 3 of x divided by x is how much? So if you have studied limit, then this is going to be a very simple question for you, right? So there are three ways of doing this question. Let us see. What you should know if you want to solve this question just by looking at it. You should know some of the things like limit x tending to 0, sine x by x is equal to how much? It is equal to 1. Right? I hope you guys know this. Similarly, there are other things also. Limit x tend to 0, cos x is equal to 1. Remember, there is no divided by x here. Okay. And then similar to sine x, we have a property for tan x is equal to 1. All right. So I hope you guys remember this. There are many several limit related properties similar to these things. Okay. So now if you know this, what can we do? How can we use this in this question? So you see, we can write this expression as sine of 2 by 3x divided by 2 by 3x. And since we have introduced 2 by 3 from ourselves, we have to multiply by 2 by 3 on the outside also. Okay. All right. Now, when x tends to 0, does 2 by 3x also tends to 0? Yes. So can we call 2 by 3x as u and replace the limit as u tends to 0? Right? We can do that. So this expression will transform into u tends to 0 sine of u by u into 2 by 3. Can we take this out of the limit? Yes, we can take this out. So what is the final simplification of this answer going to be? 2 by 3 into 1, that is 2 by 3. So option A is the correct answer. There is another way. If you don't remember these things, another way is to use L'Hospital rule. What does that rule tell us? So if you have some limit x tending to 0 or x tending to infinity fx by gx, and no, both of these become 0, then you have a 0 by 0 problem or infinity by infinity problem. Then what can you do? You can actually differentiate the numerator independently and also the denominator independently, and the answer is not going to change. So you can replace this by f dash x g dash x. And often when you do these things, you will see that the complicated part like the 0 by 0 will get cancelled, and you will end up with some constant or some whole number, and you can write that easily as the answer. So let's do the same thing in our this question. So we have limit x tending to 0 sine 2 by 3x divided by x. Let's apply L'Hospital rule. Why we can apply? Because sine of 0 is 0 and x will go to 0, so 0. So 0 by 0 is there. So that means this is eligible for L'Hospital rule. So let us apply. What is the differentiation of sine x? It is cos x, but we have constant also. So it is going to be cos of 2 by 3x, and by the chain rule, now we have to differentiate 2 by 3x. It will be 2 by 3, right? And what is the differentiation of x? It is 1. Remember that we are differentiating with respect to x only. Okay. Now what are we ended up? What did we end up with? We have limit. Let's take again 2 by 3 outside. X tends to 0, cos of 2 by 3x. Now, is this a difficult thing to solve? No, right? Because when the argument of the function cos tends to 0, then cos becomes 1. So we can simply replace this thing by 1 and we'll have the answer 2 by 3, right? So you remember I told that when you do this L'Hospital rule, most of the times that complicated part that you have in your question, we will end up removing that part from your equation, and it will become much more easier. So either you can remember these equations, because they also come in handy a lot of times, or you can always try to use L'Hospital rule when you are stuck, and you can see whether it works or not. All right, let's go to the next question. So here what I will ask you to do is to use certain concepts that we have seen here and solve these questions. Before we go there, let me also kind of add some more things like this. When x tends to infinity, what happens to sine x by x when x tends to infinity? What happens to cos x by x? So we don't need any kind of L'Hospital. We don't even need to apply that rule. But just by logic, you see you see these two things, and you can tell me what is going to be the answer. So maybe I will go here. Yeah, let us go here, and you try to tell me what is the function for sin x. I'm going to draw it here. I'm going to remove it, erase it after some time. So the function for both sin x and cos x. So let's start with sin x. Stays between -1 and 1, right? With a period of 2 pi, right? Where this is the x. So pi and 2 pi like that. This is goes to 1 at pi by 2 and -1 at 3 pi by 2. This is the sin x. What about cos x? Cos x is half a degree of, sorry, pi by 2 degree of, and goes something like this, right? So whatever you put inside the sin x and cos x, their maximum value is not going to go beyond the magnitude of 1, right? But what you are doing, you are in the numerator, you have that sin x and cos x, but in the denominator, when you go to x tending to infinity, you are linearly increasing the value of this function, right? So at x tend to infinity, the denominator is going to be very high compared to the numerator. So what do we know in case of that fraction? When numerator is very low with compared to denominator, then we can give the value of that fraction as 0, right? So the value for this expression is going to be 0. So just remember this also. that when we have just a minute, let me erase this. Yeah, so when we have limit of sin x by x extending to infinity, cos x by x extending to infinity, then the answer is 0. Okay, now let us see these two questions, these other two questions. So we have sine square x by x, or you can even write this as sine x square. This is not sine of x square. Don't get confused with that. Now, how do we solve this? Let us see. So, you can write this as limit x tending to 0 sine x by x whole square into x. Can we not write this like this? We can write, correct? And what do we know about sine x by x? Limit extending to 0, it is 1, right? So can we write this as 1 and x, and then we can keep that constant outside the limit? Then what happens to limit extending to 0 for the x? It becomes 0. Okay. Now if you are confused, let us try to solve this using L'Hospital rule. Let's differentiate. Sine square x differentiation is what? 2 sine x. This is the differentiation of x square, right? And then we have to differentiate that x. Basically, I'm trying to say that this is the differentiation for x square. But then this x here is actually sine x. So we have to differentiate that also from the chain rule. So it will become cos x. This is the differentiation of numerator. What is the differentiation of denominator? It is 1. Okay. Limit x tending to 0. Now you can easily put x value as 0 and you can find out 2 into 0 into 1 divided by 1 is 0, right? So you can easily solve this question using L'Hospital rule also. This is 0. Now let us come to this question. This is a little tricky question, so you can spend some time in solving this question. Let's see. Limit x tending to infinity, x minus sin x divided by x plus cos x. Alright, now let us see whether we can solve, because if you see this also becomes like infinity by infinity, right? This also takes the form of infinity by infinity. So let us see if we can solve this question by L'Hospital rule. So let's differentiate the numerator 1 minus cos of x. Let's differentiate the denominator. Sorry, just a minute. Yeah. 1 minus sine of x, because cos of x differentiation is minus sine of x. Okay. Can we now say with certainty what is going to be the value of this? No, right? Because x tends to infinity, cos x can vary between minus 1 to 1, and sin x can vary from minus 1 to 1. So we are still not very certain what is going to be the value, because the numerator can either be 0 or it can be 2. Same way the denominator can also be either be 0, can be 2. So we still don't know what is going to be this function, what is going to be the value of this function. So let's not apply L'Hospital here. Let's just try to do one simplification to this question. Limit x tending to infinity. Let's divide the numerator and denominator by x. 1 minus sin x by x divided by 1 plus cos x by x. So by this time, you guys might already be aware of what I am trying to do, right? Now what I am going to do? I am going to take this limit inside the fraction. So 1 minus, because it is constant, the limit of 1 is going to be 1, whatever the value of x will be. So we can write this as this 1 minus limit of x is tending to infinity sin x by x, and 1 plus limit of x tending to infinity cos x by x. And what did we see just here? What is the value of sin x by x limit x tending to infinity? It is 0. And similarly, cos x by x at x tending to infinity is again 0. So then what is the final value for this answer? It is 1 minus 0 by 1 plus 0, that is 1. Okay, so you see, you can try to use L'Hospital rule whenever you see 0 by 0, infinity by infinity kind of scenario, but it may not work always. So I wanted to show that using this problem, and in those cases you have to use the you have to try to simplify the question first. Okay, all right. Let's come to the next question. Question number 2, GATE 2008, question number 22. The value of integral 0 to 3, integral 0 to x, 6 minus x minus y dx dy is. We have option 13.5, 27, 40.5, 54. Okay, so this is integration based question, double integration, pretty simple question. Just you have to know one thing. Whenever you have this kind of integration, and then you are given something like some constant here, and then in the inner limit you have some kind of function of x and another function of x, and then you have some other um, function of xy here, and then dx dy. What do we understand from this question? We need to understand two things. First, that this limit, whenever the limit given to you is in form of one variable's function. So you have two variable here, x and y, and the limit is given in the form of one variable. Then that limit is for the variable other than the variable in the limit. So you have the limit as 0 and x here for this example. So this limit is for the variable y that is excluded from the given limit. Okay, I hope I am making sense here. So the limit, if it is in the form of x, then it is going to be the limit for y. Similarly, if you have three variables, then how the limit for z will look like? How the innermost limit will look like? It will look like some function of x and y. So the variable which is not in the lower bound and the upper bound of the limit, that is the variable for whom the limit is assigned. If you know this, then you can solve this question. What is the second thing that we need to know? Second thing we need to know is, so even if you have a function, you have a variable in the limit, when you have the same variable inside the function also which you are trying to integrate, when you are integrating this function with respect to y, you have to assume x as constant. So when you are going to integrate this function for the first time with respect to y, you are not going to integrate x as x square by 2. Okay, you are going to treat x as constant. What do we mean by that? We mean when you integrate this, you are going to get 6y, right? Similarly, you are going to get xy, because it is 6 into integration of 1, that is y, and x into integration of 1, that is y. Alright, so let's start solving this question now. So you have 0 to x, 6 minus x minus y dy dx. So once you integrate the inner portion, you can keep 6 minus x as a separate singular constant. So you have 6 minus x y minus y square by 2. That is basically the integration of y dy. And the limits are 0 to x. And then you have to further integrate this to 0 to 3 for the x. Okay, so what do we have to do? We have to first put the value x and then 0. So the final outcome of this expression is going to be 6 minus x into x minus x square by 2 dx. So this is the result of the first integration. Okay, now what do we have to do? We have to integrate this again with respect to x. So before that, let's do a simplification. So we have 6x minus x square and minus x square by 2. So let's just write this as 3x square by 2 dx. Now we have to integrate this. So we have 6x square by 2 minus 3x cube by 2 into 3 or 6. The limit is 0 to 3. Further simplification will show that this is 3x square minus x cube by 3. Sorry, x cube by 2. Let's put the values. 27 minus 27 by 2. So answer is going to be 27 by 2. What is 27 by 2? 13.5. So this is the answer to this given question. Do we have 13.5? 13.5 is the option A, and that is the correct answer. Okay, so I hope you were able to understand this question. Similarly, they can give in 3 variable also, but you have to remember what I said. Whatever is not in the limit, most likely or always, that variable is the one for which the limit is given. Okay, now let's go to the last question for today. This is related to gradient. So if you remember, in our previous sessions, I have discussed with you guys that you have gradient, you have curl, and you have dot product. So what is the use of gradient? The gradient is used to get a vector from a scalar. So you differentiate this scalar, which is most likely going to be function of multiple variables. You differentiate this scalar partially with one variable, and then you put that in the x coordinate. Let's say if you have differentiated with x, so you put that in the x component of the vector, then you differentiate the variable, so the function with another variable, put it into another component, and then you differentiate the variable with, sorry, the function with another variable, put it into another component. So this is what is gradient do? Gradient converts your function or a scalar to a vector. Similarly, what does dot product do? So gradient is written like this. You have your inverted delta and the function. What does dot product look like? Dot product looks like this. So you have a dot in between, and it is done to a vector to get a scalar value. And what does curl look like? Curl is also done on two vectors, but it yields another vector. Right, so remember these concepts, that gradient, dot product, curl. Lot of questions have come previously in GATE regarding these things. So this question, let's read this question. So question number 3 for today. GATE 2009 question number 2. For a scalar function f of xyz is equal to x square plus 3y square plus 2z square, the gradient at the point P1, 2, minus 1 is. So when they are asking us the gradient at that point, basically they are asking what is going to be the value of your this expression when you substitute the value of x, y, z as 1, 2 and minus 1 respectively. Okay, so let's first get the general expression of this gradient. So gradient f of x, y, z is going to look like the partial differential of this function with respect to x I cap plus partial differential of this function with respect to y, and then partial differential of this function with respect to z and k cap. So I, j, k basically are the unit vectors in the x direction, y direction, z direction, and that is the maximum that is there in our syllabus, the 3 dimensions. So we are going to limit to that only in terms of vectors. So when I say partial derivative, then I think you all are familiar, but just I'm going to repeat that when you are doing a partial derivative with respect to one variable, you treat all the other variables as constant. So the partial derivative of this function with respect to x is going to be 2x. What about this? There is no x here. That means this is a constant for this function. So this will be 0 and this will be 0. So you have 2x I cap plus, again we have to partial differential of this function with respect to y. So you have 6y j cap, and then this one is 4z k cap. So this is your gradient of this function. Now let's put in the value of x, y, z. 2 into 1 I cap plus 6 into 2 j cap plus 4 into minus 1 k cap. So you have 2 I cap plus 12 j cap minus 4 k cap. So we have the 2, 12 plus 4, no, minus 4. We have option B. Option B is the correct answer. Right? So I hope you understood something from this expression. Alright, do we have a time for another question? Let us see. Yeah, let's take this another simple question. Question number 4, GATE 2010, question number 2. Basically, this is a very easy probability question. So, two coins are simultaneously tossed. The probability of two heads simultaneously appearing is. These two coins are tossed simultaneously. Right? So, what is the chance that you are going to get heads simultaneously? So, what do we mean by this? See, you have tossed the two coins. What is the probability of getting heads in one coin? 1 by 2. What is the probability of getting heads in two coin? In the second coin, independent of the first coin? Again 1 by 2. So then what is the probability of this event occurring together? Both the heads. Let's take a look at the sample space. What can be the possibilities? You have head head, you have head tail, you have tail head, and you have tail tail. Right? This is the sample space, and you are asking for the probability of head head. What is it going to be? It is going to be, either you can write it as 1 by 2 for 1 into 1 by 2, 1 by 4 by using the logic of continuity, or you can write it as you from this sample space as 1 by 4. So option C is the correct option. All right. So I hope you are able to get something new from this course. And this is that's all for today's session. And we'll meet again tomorrow from 6 to 7. Okay, thank you.